squares are mostly the things that we're looking for. Make sure at the top of your paper you've identified that this is 11.2 simplify radical expressions. And our essential question of the day is, what does it mean to simplify a radical expression? Make sure that's at the top of your page. Perfect squares are numbers that square root nicely, in that they give us a nice answer. Something like the square root of 5 is not a perfect square because there's a nice number that multiplies together to get 5. So a good list of perfect squares is 1, not 2, 4, 9, 16, 25. All I'm doing is I'm taking the numbers 1 squared, I get 1. 2 squared, I get 4. 3 squared, I get 9. 4 squared, I get 16. 5 squared, I get 25. So all I'm doing is just squaring numbers and then listing those out, but I'm doing it in my head. 7, and then this one I did out loud. And it keeps going. There's an infinite number of perfect squares. A radical expression is an expression that has a radical in it. So we could have square root of x. That's a radical expression. We can also have something we can put a number in front of it. We can even have something like this, where we've got a number in front of it and a number inside of it. What we're looking for with these simplified radicals is we have no perfect squares except one in the radicand. So the radicand is right in there, that 3, or right in there, that x. So that's what's inside of the radicand. So that x and the 3. We also don't want fractions in there, so we want to try to get rid of fractions. And the radicals in the denominator and the fraction, that's super bad. We're going to talk about that more next time. But we don't want radicals in the denominator. That's a big no-no. All right, so to do that, we're going to use this thing called the product property. If you've got two things being multiplied inside of a radical, so they're in the radicand, then you can break it up. If they're together, you can break it up into two separate ones. So what we're going to always try to do is this first thing, we want to be a perfect square. And then the second thing, we want that to be a non-perfect square. So the 32, I want to break that up into two numbers. One of them is going to be a perfect square, and the other one is not going to be a perfect square. And this is kind of like our leftover stuff. This one is going to be a nice perfect square that we can use. So we want a perfect square that's a factor of 32, and the easiest way to find that is using that list of perfect squares that we've got up top. We want to find one that divides 32. So we don't want a number that's bigger than 32, so we just have to check these numbers. Of all of these, whichever one's the biggest that divides 32, that's the one we want. We can even do that on our handy dandy calculator. So the biggest one that's smaller than 32 is 25. So we check, can we do 32 divided by 25? No, it gives us a decimal answer. So we don't want to use that one. The next one after 25 is 16. So can we do 32 divided by 16? Oh boy, howdy, we can. We can make it a 2. So we're going to break that up into those two numbers. So we're going to make this, I need an equal sign there, the square root of 16 times 2, which is the same as the square root of 16 times the square root of 2. Now that we've done that, we can square root 16. It's 4. 4 times 4 is 16. The square root of 2 is nothing nice. You can even see it on your calculator. Go to your calculator and go second x squared button, you can get 2. So the square root of 2 is not nice. We don't cut numbers in half. It's a gross decimal. We don't want to write that. We ain't got time for that. It's a number that will never repeat and it will never end. I ain't got time to write all those digits. So we're just going to write the square root of 2, and that is going to be my answer. You can also do this with exponents. We just talked about that earlier. But with exponents, it's even easier. You don't want to look for a number that you can cut that divides 7, excuse me. All we want to do is we want to try to cut them in half. So even numbers are easy. All you got to do is take that even exponent and cut it in half. So you get 6. So we get y to the 6. If we've got an odd, though, it gets a little bit trickier. We want it to be an even. So we make it into an even and a 1. It's always going to be that, an even and a 1. So the even that's closest to 7, but smaller, is 6. So we're going to make this the square root of x to the 6, and then a regular x. Oh, that's pretty gross. Let me clean that up a little bit. X to the 6, and a regular x. That will get broken up just like the one above it, where we get the square root of x to the 6th and a square root of x. That even exponent, we can chop that in half. So we get x to the 3rd. And the square root of x is just the square root of x. Done. Next, these other ones, we're going to combine those two ideas together. So we've got a number and a variable. So what I do instantly is I'm like, you know what? That's not one problem. That's 2 problems. I'm really trying to do 2 separate problems at once. And that's the way I break it up. The very first thing I do is I break it up into those 2 problems. The square root of 32 and a square root of x to the 4. Let's make that a little more clear. And then you're going to solve both of those questions and put them together. So the square root of 32, we just did that over here. So via the same thinking, we should get 4 square roots of 2. And then we've got x to the 4. That's an exponent. And when you square root an exponent, you just cut it in half. So we get x squared. And now we want to just kind of clean this up. It's considered polite to put the square root as the last part of your answer. So while these are being multiplied together, we can rearrange their order. We can put the 4x squared first and the square root of 2 last. I'm going to do one more here, and we're going to be done for this video, and then we'll do a second video for the back side. It'll be much shorter. Once again, we want to break this up into 2 problems. We got the square root of 63, and we've got, I'm going to use teal, the square root of y to the 8. So the square root of 63, I want a perfect square that's smaller than 63. So 64, I don't want to use because that's bigger than 63. So I want to start with 49. So I'm going to use keyboard. I might go a little faster. Yeah, keyboard's much, much faster. So 63 divided by 49. Does that work? No, gross. What about 63 divided by 36? Does that work? No. Okay. What about 63 divided by 25? See how I'm just kind of working my way down my list? Okay, that one doesn't work. What about 63 divided by 16? Does that work? Nope, that doesn't work. 63 divided by 9. Ooh, got one. Sweet, 7. All right, so I'm going to break up that 63 into a 9 and a 7. All right, back down to this problem. So we're going to make this the square root of 9 and the square root of 7. The y to the 8, that's a nice even one. So if it's an even exponent, you cut it in half. Y to the 4. The square root of 9, that's easy. 3 times 3 is 9, so the square root of 9 is 3. The square root of 7, that's kind of the other thing, and it's going to be kind of this garbage answer. So check it out. If we do the square root of 7, it's nothing good. I don't like that. I'm not going to write all that. I'm just going to write the square root of 7. That's easy. I like easy. All right. Now, the last thing is I want to clean up this answer a little bit. So I want to put the radical at the very end. So I'm going to put the 3 and the y to the 4 first. And we're going to put that square root of 7 at the very end. That's it. I'll see you in the next video.